Good afternoon. Welcome to Automating System Center Deployment with the Powershell Deployment Toolkit. I am Rob Willis. I am a Principal Program Manager in the Windows Server and System Center PM group at Microsoft. Our team is a little different to some of the other teams that you may be familiar with. We don't have responsibility for any given feature or component. We're a team that has responsibility for, amongst other things, delivering knowledge about Windows Server and System Center and cloud in general through, currently our primary mechanism for that is through our blog. So in the keynote on Monday, there are a number of things that Brad mentioned that actually are directly from my team. Firstly, the SharePoint service template that was featured in, I think, the first demo during the keynote. It was my team that built that service template. The Building Clouds blog that Brad referenced, that's my team's blog. And the PowerShell script that he referenced is the PowerShell Deployment Toolkit. I'm the guy that built these scripts and knowledge. So for those of you that follow people on Twitter, I have a limited number of Starbucks cards. If you follow us, follow @building_clouds on Twitter, by the end of this session, the first 30 or so of you, I'll give a $5 Starbucks card. It's not enough to actually buy a coffee in Las Vegas, unfortunately, but I guess it's the thought that counts, right? So how many people were here last year for the System Center Unified Installer session? Okay, a couple. How many people actually used the System Center Unified Installer? Not very many. It's about what we thought. I was actually the program manager for the Unified Installer. We learned a lot through that process, and a lot of what we learned went into the PowerShell Deployment Toolkit. So I'm going to start with some questions, and for those of you who were here last year, these are more or less the same questions. How many products are there in System Center 2012 SP1? Shout them out. How many are there? 8? 9? There's one. System Center is a product. You can't buy them individually. There's one product, licensed, marketed as a single product. How long does it take to deploy System Center 2012 SP1? Yes, all of System Center. How many? 2 to 4 hours? How big is my budget? We get answers anywhere from a couple of days, a couple of weeks, a couple of months, if you've got a services partner involved sometimes. The answer is just it's too long. How many screens do you go through when you're actually running an installation and you're doing all of System Center, including SQL, including all the prereqs you have to go and install? Just take a wild guess. How many screens do you think you run through? 200? 280? For the Unified Installer session last year, I actually counted them. It was 422. For the type of deployment that we can do with PDT, the PowerShell Deployment Toolkit, I lost count around 500 and I just gave up. It's a lot. How many post-setup integration tasks are there? This is not configuration of any given component. This is integration between components. What on earth is post-setup integration? You know, we find a lot of our customers don't even do some of that. And a lot of the value of System Center as a product, as opposed to 7 individual components, comes from the integration between them. Okay, who's afraid of XML? I just said XML. This is now a 400 level session. Okay, don't be afraid. PowerShell Deployment Toolkit does involve manually editing XML to make it do what you want it to do. Don't be scared. It's actually very, very easy. So I'm going to start with a demo. Hopefully the network will stay up for the duration of this session, but we'll see. So let me switch over to my demo system here. Don't worry about this right now. I'm going to explain through the course of the session everything that you can put in this, but I'm going to do 2 full deployments during the course of this session. One is a deployment of every single component of System Center, including all that post-setup integration, and that's this one. And this is the XML file that describes that deployment I'm about to go and do. So I'm just going to kick it off. And the only reason I'm doing this right now is because it takes a little while to run, and I want it to be finished by the time we finish so we can see what it's done. So this is basically the user interface for PDT. This is telling you what it's doing. And we'll switch back to this a couple of times during the course of the session so we can see where it's gotten to. The second one I'm going to do is a slightly different deployment. This is a full high availability deployment. So this isn't all of the components, but this is a SQL cluster, clustered VMM, and multiple instances of both App Controller and the Service Provider Foundation. This might be a very typical service provider deployment. So again, this is the XML that describes it, and I'm just going to go here, kick it off, make sure it actually starts, and then we'll switch back to the deck. So we'll revisit those deployments as we go through the session here. So what is System Center? I say it's one product. In reality, there's a lot to that one product. There are 7 components within System Center. Some would argue there are 8. Officially, there are 7 components within System Center. Some of these were previously available prior to 2012 as individual products. We now consider these as components of System Center. So that one product is 7 components. But it's more complex than that. Each one of those components has a number of roles, some of which you require, some of which are optional. And this is by no means every role that's part of System Center. This is actually the set of roles that the PowerShell Deployment Toolkit can deploy. Configuration Manager, for example, has a lot more roles than are listed on here. But it gets even more interesting than that. Each one of those roles has a combination of one or more prerequisites that you need to install. This is the list of prerequisites that you need to know about to install System Center. I think I got them all, but I'm not absolutely convinced. The point is, it's a complex installation. We understand it's a complex installation. PowerShell Deployment Toolkit is all about making it possible to install it as a single product so that you can get the full benefit and functionality of the technology that you've paid for. You've bought, you've paid for, you've licensed, I hope, all of System Center. Why not take advantage of that? So what do you do to go and install System Center today? First, you define your deployment. I don't care how many automation tools you have to do your planning. Right? Don't skip planning. You have to define what your deployment is going to look like. Then you've got to go download all the bits. Well, actually, what you probably do is you run setup, and it says you're missing the SQL Server command line utilities. So you go back and you find those, and then it says, well, actually, you need the native client first before you do that. So you go and you find those. But at some point, you've downloaded a whole bunch of stuff that is used as part of the System Center deployment. Then you get a set of servers that you're going to deploy it to, whether those are physical, virtual, whatever virtualization platform you're using. You get a bunch of server OSs that you're going to install to. Then you create some service accounts, if you can figure out what service accounts you need. Then you go and you log on to each one of those servers. You install the prerequisites after running setup a few times to figure out what prerequisites you need. You install SQL, and then you install SQL again when you realize you missed a feature of SQL that you need for that particular deployment. And then you grant the service accounts you created the permissions, so which ones need to be administrators on that server or not. Then you install your first server role. And then you may install other server roles. And then you figure out how you make people administrator of that component so they can actually access the functionality of the component for the role you just installed. And then maybe you know about this post-setup integration thing, so you do that. Then you install a console somewhere else, and then you run that console and it says, what do you want to connect to? Unless it's Configuration Manager, in which case it already knows. So you then connect the console to the server you want it to connect to. You install some agents, and finally, you get to manage something. Okay, that is the experience, the manual experience of deploying System Center. With the PowerShell Deployment Toolkit, it is pretty dramatically different. We don't replace every single one of those things, but we dramatically simplify the experience. So what I'm going to do is walk through each one of those things and explain how PDT simplifies that experience. Starting with defining your deployment. You still need to define the deployment. And this is where the first one of our XML files comes in. There are a total of 5 files in the PowerShell deployment toolkit. It's a 70K or so download. It's a tiny little thing. The only one that you edit, that you have to edit, is this thing called variable XML. This defines what PowerShell deployment toolkit PDT is going to install for you. There are some global settings you have to put in there, so the registered username and company name that you provide when you're installing things, what service account you want to use for the actual installation itself. This isn't service accounts for the components, this is for the installation itself. What the source path is to the bits for installation, and we'll get to that in just a moment. And then optionally, you can also provide the product keys. If you don't give it product keys, it installs in eval mode. If you do, it will install in license mode. And then there's some settings you specify for each component. Typically, that's just the service account and the password for that service account that's used by that component. In a couple of cases, there are a couple more, but we highlight what those are for you. And then you say which server each one of the roles you want to deploy is going to be installed to. Give it an FQDN for the server that it's going to be deployed to. If it's a database role, you have to tell it what SQL instance you want to use. And then if it's a database role, you also have to tell it which version of SQL you want to use and who you want to be the administrator group for SQL. That's it. The installer itself will validate all of these settings for you before you do your deployment. So don't worry about manually editing XML. If you get something wrong, we're not going to attempt to deploy something that we know won't work. So this is a sample variable XML file. This is a simple one. This is just a simple orchestrator installation, but I want to use this to highlight actually how simple it is to provide this information. So here is our installer service account and password. And yes, the passwords are in here in clear text. This is sample code, not Microsoft supported product. Then per component, so in this case for Orchestrator, I have to give Orchestrator a service account as well. If you want to use the same service account, you can, that's fine. We don't force you to make any of those different. Then you specify which servers each one of those roles is going on. So even though this is Orchestrator, this has the five of the roles that Orchestrator can deploy, but you can put them on the same server. Right? So you'll see here the management server, the primary runbook server, the web component server are all going to the same system. And then here's my SQL information. I'm using SQL Server 2012. You can use SQL 2012 for everything with one small exception, and that's DPM with a local database instance. And optionally, I could have also provided the product keys, but I don't feel like putting my product keys in a deck that's been handed out and recorded. So in this case, I'm just doing an evaluation install. Okay, so that's it. I've defined my deployment. If I were doing multiple components, obviously I'd have multiple component sections, and I'd have more role and SQL sections in that file. But I've now defined my deployment. Then I have to go and get all of the stuff, all of the installation bits that I need to go and do that deployment. For that, we have a script in PDT called the downloader. Anybody want to guess how many things you have to download for a full installation of System Center? A bunch? 200? No. 33 gigs worth. Really close. It's actually 56 different things you have to download. And yes, in this case, I did count them. So the downloader goes and gets all of those for you. It gets the evaluation versions of the System Center components, and I'll explain evaluation versus license a little bit later on. It gets all the prerequisites. It downloads evaluation versions of both SQL 2012 and 2008 R2. It gets the SharePoint Foundation edition if you're installing Service Manager. It actually gets an eval version of Windows Server as well, because a lot of these components need .NET 3.5.1, which is on the external media for Windows Server, not included in the installation itself. It downloads a few management packs. Actually, they're only the ones that are needed for integration, and then it also downloads the integration packs for Orchestrator. And then it extracts them. So some of these things come down as ISOs. Some of them are zips. The system center components are actually WinRAR files. So anything that needs to be extracted, it will automatically go and extract them. Some of these things need to be run to then go and get other things you need to install. So ADK, the Automated Deployment Kit, which is used for both Configuration Manager and Virtual Machine Manager, is a 1 meg download that you run, and it downloads another 1.5 gig. So it runs that for you. It also runs the downloader from Configuration Manager. So if you're doing an offline deployment, everything you need is already there as part of this downloader. And if any of the downloads that we've done are self-extracting executables, it will extract them for you. So it does absolutely everything you need in terms of getting the media there. It will also slipstream SQL Server 2008 R2 for you with SP2, so you don't need to worry about how to do that. Because of what we need to do, this must be run on Windows Server 2012 or Windows 8. That's because I need to mount the ISOs, and that is native in 2012. You also need WinRAR installed to extract the System Center components. There is one option on this script that is, make sure I don't lose my network connection here. One option on the script that is deployment only. By default, if you run downloader, it will download all 56 things. If you do -deployment only, it will look at your variable XML file for the deployment you're about to do and only download what you need for that particular deployment. And the whole thing is restartable. It downloads around, I think, 15 gig. It extracts to about 35 gig. So let's take a look at the downloader. So I have a couple other systems here I'm going to use for this. Note on here, in this folder, there is no installer. Right? There's a bunch of VMs already running on this system, but there is no installer folder, and that's the folder that I've told this particular system to download to. So I just run downloader. It goes through all 56 of those components, all 56 of those downloads, determines which ones of them you need. If you've already downloaded one, it would skip it. That's the restartable part. And then it'll just go off and download them all. This is running in one of our data centers in Redmond, which has a really, really fast internet connection. It takes about an hour for it to download everything. On my connection at home, which is still pretty fast, it takes about 4 hours. But it takes as long as it takes based on whatever bandwidth you have to go and download all of that. This second system here, I'm going to do a different download. In this case, again, no installer folder, but in this case, I'm going to do downloader deployment only. So instead of 56, it calculates for orchestrator, which is the variable file on this system. It only actually needs 8 of those, so it's just going to selectively download the ones you need. And then if something's missing, so another system here. So in this case, I'm going to make something be missing by deleting it. So if I were to go and delete Silverlight from my already downloaded set of media, and then go and run the downloader, it goes through all 56 to determine what's missing, and then it's just going to download that one thing that I have missing. So there, very quickly, that one download, and it goes through and makes sure everything's extracted again after the fact. So as we release new versions of PDT that maybe do more functionality, that maybe needs additional prerequisites, if you've already downloaded everything, you run downloader again, it'll just refresh that with any of the new content we need. And one of the reasons we included a downloader in this was because it was easier than explaining everything you needed. Right? I like to document in PowerShell and XML. I don't like writing documents otherwise. So that's it. I've defined my deployment. I've downloaded all my bits. I need to go and install all my server OSs. For that, we have something called the VM Creator. VM Creator is completely optional. The only requirement for PDT is you have Windows servers that are domain joined, that have WinRM enabled, that you have administrator access to. So if you already have physical servers you want to install to, if you've got existing VMs on Hyper-V, VMware, Zen, whatever it happens to be, Azure in IaaS, we can use them as long as they're the right Windows Server version, they're domain joined, WinRM is enabled and you have admin access to them. If you want to create them, we will help you create them on Hyper-V. We will not help you create them on VMware for obvious reasons. So all you do for the VM creator, if you want to run it, is say, how many servers do I need in my deployment? Specify some defaults, so which Hyper-V hosts I want to go and create them against, some information about name, how many processes you want to allocate, memory, and it will take a prefix and count for things like name. So you can just say server 1, and I want 5 of them, and it will create server 1, 2, 3, 4, 5. There's a full example in the actual PDT download of all of the parameters you can specify for VMs. If you want to override any of these for any individual specific VM, so you want it to have a specific name or be on a different Hyper-V server or have a different amount of memory allocated, you can do that per VM. And then the creator will actually check that everything that you need, so the parent disk that you need, the virtual network you're connecting to, everything exists, so it's actually able to go and create it. What it actually does is it creates the VM either by copying a VHD or creating a differencing disk from a VHD, mounts that VHD and inserts unattended XML text into that. So during the startup of that and the sysprep of that VM, it will join a domain, it will enable WinRM, it'll add the installer service account. So by the time that VM or that set of VMs is running, everything you need to deploy against them should be ready. This is a snippet of the variable XML file that defines how to do this. So here you see I have my defaults for servers. So I'd say server 11 is my first one, and I'm creating 3. So I should get 11, 12, 13. But I've actually specified for one of them, I want to have a different amount of memory allocated to it, and I'm going to give it a different name. So I'll actually get SQL 01 and then server 11, 12. Let's take a look at that. So go back to make sure I'm on the right system here. VM Creator just reads the variable XML file and then creates the VHDs. It'll either copy them or create them. And then a little bit further down here, you'll see it'll say inserting unattend. So it's creating data disks right now. Then it mounts that VHD, it inserts all the unattended information, modifies it with whatever you've specified, so your domain join credentials, and what domain you're joining, etc. It'll just run through all those, start them, and then by the time it's finished, it takes, depends how fast your Hyper-V servers are, but maybe 20, 30 minutes before all those VMs are spun up, created, and ready to go. I also want to give you a glimpse into a new version of this that we're working on. VM Creator assumes you have existing AD right now. So it will add new VMs to an existing Active Directory infrastructure. It won't create AD for you. But we have a lot of feedback. I've had some feedback that's saying, I want to create whole labs with this, and I don't necessarily always have AD in place first. So the next version that we're going to release will also create AD for you. So in this case, what you're seeing is when it gets to the point where it mounts that VHD, it will add some additional information. Right, so here, I've added a setup complete command. I've also set up auto login, and then I'm actually copying the installation media into that for the deployment I want to do. So this will create the VM. That VM will auto log on, create AD, reboot. All the other VMs will wait for AD to finish before they start. When they start, they'll join AD. When their domain join is finished, the domain controller then has the installer script in there, and it will just automatically start that and go and do the deployment. So you've got a one-step, create me a full lab with AD, all my VMs, and my System Center deployment in there. That was the sneak peek at VM Creator with Active Directory. So, what's next? You still have to manually create your service accounts. Again, I'm thinking of another edition in the next version of this that will create those for you. We don't assume right now that you have any additional access to AD than just a regular user, but I've had a lot of requests for adding that. So the next thing here is, normally what I would do is I'd log into each server. You don't have to do that with PDT. So this is really part of the magic of how this thing works. We do remote installs. We don't log onto a system to do the installation. We remote install everything, right? There are two requirements that we have to do that. We have to be able to run a command remotely on another server, and we need credentials delegation when we do it. What I mean by that is if I'm installing the Operations Manager management server, the first one, on a remote server, it has to be able to create a database, potentially on some other server. So in Windows authentication terms, that's considered credentials delegation. There's a number of different options for how to do this. You can start a remote process with WMI, but there's no way to get credentials delegation with that. WinRM is the obvious answer. WinRM by default, even in the default configuration in Windows Server 2012, doesn't have credentials delegation, but WinRM with CredSSP does. However, there's a problem. There's two problems, actually. One of them is that any component that configures WinRM during its installation could potentially restart WinRM, and it will then kill your connection. VMM actually does that. But the bigger problem is actually Windows Update, Microsoft Update. Even if a component isn't necessarily installing an update, even if all it's doing is checking to see whether a certain update is already installed, that gets blocked on any remote install. So the Windows Update standalone installer, wusa.exe, has specific code in there that does not allow you to remotely install a Windows Update. DPM does this, SQL Server does this. There's actually a couple of others that do it under certain circumstances. So we can't use standard remoting technologies to do this. PSExec is another option we have. PSExec, if you provide it with a user credentials when you run it, it will get credentials delegation. However, same problem. Microsoft Update, WUSA blocks on that. PSExec with the system switch doesn't block on it because it's actually a local authentication, but it doesn't get credentials delegation, so we still can't use that. Orchestrator Run Program is just a modified version of PSExec, so it won't work. The Orchestrator Runbook server is actually how we solved this with the unified installer. We used the Runbook server kind of like an agent. It runs as a service and it has a service account that it runs as, and so it's actually a local authentication, which is how we were able to do that in the 2012 unified installer. However, there's lots of other problems with using Orchestrator to do this. So what we actually ended up with for PDT is the task scheduler. Task scheduler is interesting. You can remotely, and what we actually do is we remotely create a task against a machine without a trigger. Right? So it's a scheduled task, but it has no schedule. Then we start that task. Because it's running as task scheduler, it runs as a local service and actually has a local authentication. It's not considered remote by Microsoft Update, and it gets credentials delegation to be able to create something against a remote machine. So task scheduler just happens to be part of Windows. You get in a lot of trouble if you actually turn it off these days because Windows uses it itself. So we use task scheduler as the remote execution for PDT. Okay, so I don't need to log on to all my servers. What do you think comes next? Everything else. It would be a really long session if I had to go through each one of those. Now, actually, once we've got to this point, the PDT installer, which is the main engine part of PDT, does everything minus installing agents. So this is the engine. This is the core piece of code that does all the work. It is essentially a distributed deployment controller, right? So it knows that I've got to install a bunch of things on a bunch of remote systems. It knows how to manage the sequence of installation of those things. knows how to validate whether something needs to be installed, and after something is attempted to be installed, whether something has been successfully installed, and then how to manage dependencies between multiple servers, right? So big difference between MDT, Microsoft Deployment Toolkit, and PDT, PowerShell Deployment Toolkit. MDT sequences things against a single system. PDT sequences things across multiple systems, including dependencies between those systems. It will reboot where required, right? So if we either detect that a reboot is required, and we do that either on pending file rename operations, a update installation that flags itself as reboot required, a server role and feature deployment that flags itself as update required, or if our knowledge specifically says you must reboot after doing this, we will reboot the remote system. There's one exception to that. If the system you're running the installer on is also something that you're installing a component against, we won't reboot that system. Right? We actually treat that as a failure if it happens, and we'll talk about how we handle failures. But if we reboot that system, the central controller would reboot and everything else would basically not complete. So we don't reboot the system you're on, but anything else, if it requires a reboot, we reboot it. And then we gracefully handle failures. There are a lot of failure scenarios. Some of them are timeouts, some of them are installed software clashes that we can't necessarily detect. But if anything fails, we understand that it failed. We'll flag it as failed and stop anything happening on that system. And then any other system that was dependent on anything on the system that failed will also fail because of a dependency failure. It's actually fairly graceful the way it does it. We don't roll back, right? So we don't take everything that we've already installed and roll it all back. We stop at that failure so that you can then go and correct whatever condition caused that failure and then restart the deployment, and it'll basically just pick up where it left off. The reason it does that is because we check for everything we do before we need to do before we do it. So there's a couple of different phases that the installer goes through per server. What it actually uses is a job in PowerShell. Yes, we could have done this with workflow in PowerShell v3, but this thing was actually written about 1.5 years ago, and PowerShell v3 didn't exist at the time, so we use jobs. So there's a job running for every server in your deployment. It will do each one of these things sequentially on each one of those servers before checking for dependencies. So if I need to add a service account as a local administrator, I'll check to see whether it's already there or not, and if it's not, I'll add it. If I need to install roles and features, I'll check to see whether they're already installed or not, and if they're not, I install them. SQL clusters actually do have some dependencies. So if you do install in a multi-node cluster, it will do a advanced SQL prepare installation on all of them simultaneously, and then they'll wait for every node in the cluster to complete, and one of them that will do then the advanced complete. So there is a little bit of dependency check in there. Then if there's any standalone SQL instances to install, we'll install those, and yes, it will install multiple instances on the same server if that's what you've specified in your variable file. Then it will install all the prerequisites, and then it waits. The next thing that happens are roles. And roles do have dependencies. So when it starts to install roles, it'll check to see if that role has a dependency. If there's a dependency on some other system, it will wait until that system says that that role has been installed there, and then it will continue. Right? Then it will do some integration. It'll do all the post-setup integration and some very subtle configuration, just a small amount of configuration. But that's all the installer knows how to do. The installer itself knows absolutely nothing about System Center. All it knows is how to make something administrator, how to install a role and feature, how to install SQL, how to run some command line and check for dependencies between things. All of the intelligence, the knowledge in PDT is in this other XML file, which you can edit if you want, but don't. No, you can, and actually I kind of encourage people to do it, but be careful. All of the information, all the knowledge about how System Center gets deployed is in Workflow XML. PDT installer itself knows nothing about System Center. All it knows is how to do all those things on that previous slide. All the knowledge is embedded in this XML. It is essentially everything that we know about how System Center gets deployed. And it's very, very structured. And it's actually kind of an interesting reference to how to do certain things. It defines roles. System Center is 7 components, but honestly, the components don't really matter. What matters are roles, right? The role happens to belong to a component, but it's the role that really matters. So Workflow XML defines all the requirements for that role. So what roles and features, what Windows Server roles and features are needed, what prerequisites are needed, how to validate whether or not that role is successfully installed, what dependencies it may have on other roles. So my orchestrator management server has a dependency on the orchestrator database server. I can't install the management server until the database server is complete. What the integrations are between roles. We don't require you to specify integration. We just automatically know that if I'm installing Virtual Machine Manager and Operations Manager, there's integration between them, and I'll actually go and run that integration. You don't have to tell PDT to do it. It knows how to do it. Integrations are then actually just treated as additional roles because they are just additional things to go and install that themselves sometimes have additional prerequisites. It knows what firewall settings are needed based on the role that you're installing. So most components set their firewall settings for you. Some don't. SQL, for example, does not set firewall rules when you install SQL. If you have the firewall turned on, you need to allow remote systems to be able to talk to SQL, and so PDT knows about the firewall rules that it needs to set. Orchestrator is actually the other example. The orchestrator management server, by default, doesn't set a firewall rule to allow the runbook designer to connect to it, and so PDT knows how to set those. It defines all of the installables. What on earth is an installable? An installable is one of those 56 pieces of media that we download. Each installable is potentially downloaded and has a number of installs within it. So in Orchestrator, you can install the management server, a runbook server, the web component server. Those are all separate installs from the Orchestrator installable. And then in Workflow XML, we also define default settings for each of the components. Not everything can be defaulted. We can't default your service account, but we can default the installation location. We can default the port settings for a web server. So Workflow XML defines all of those default settings for you. And it is completely extensible. In the intro post to this that I did about 2 months ago when we first released it publicly, I said PDT can be used to deploy just about anything. Doesn't mean to say you should use it to deploy just about anything. But if somebody wanted to add to this, for example, if you always install the Veeam management pack for monitoring VMware every time you install Operations Manager, you could easily extend the workflow to install that management pack for you. My friends at Veeam will be really happy that I said that. So it is extensible. So let's take a look at it. And this is one of those ones where don't be scared because you don't have to do anything to this. So this is the workflow file. Yes, it is 10,256 lines of XML. As I said, it defines everything we know about how to deploy System Center. So it keys off roles. So here is my roles section, and these are all of the different roles that you could potentially install with PDT. Each one of these defines a set of requirements. So I use Orchestrator as my example because it's actually a relatively simple component. The Orchestrator management server requires on both Windows Server 2008 R2 as well as Windows Server 2012 that .NET 3.5.1 be enabled. It has a dependency on the Orchestrator database server. It requires a firewall rule for its management service, and then its installable is from the Orchestrator media and is just for a management server. Right? So this is the simple set of requirements for how what's needed as prerequisites, and then how to install the orchestrator management server. It also defines a set of validation. So this is saying that the supported operating systems that the management server can be installed on are 2008 R2 and 2012. Not all components will install on both versions. Not all roles will install on both versions. It also defines the combinations that PDT will allow you to make for that role. So it will allow you to combine it with any other piece of orchestrator, also any other piece of service provider foundation, because officially it is part of orchestrator, but it won't allow you to combine that with anything else. That's not to say it won't work. That's just to say that in our experience, best practice says don't install that role on the same operating system as something else. Let's look at a slightly more complex one, and only slightly, and that's the web component server. So here you see, same thing, we've got our validation rules. We've got our validation rules, but then we have more server features this time than we did before. And you'll note in this case there's a difference between 2008 R2 and 2012 in that on 2008 R2 we just have .NET 3.5.1, and on 2012 we got 3.5.1 and 4.5. But then you'll see there's a prerequisite that says on 2008 R2 we also need to install the .NET Framework 4.0. That's because it's a separate install on 2008 R2, it's a server role and feature in 2012. So it understands which, based on which operating system you're deploying against, which prerequisites to go and install. Again, we have some firewall settings and we have a dependency, so the management server has to exist before the web component server can be installed. This reference back to the installable then defines in here how that component gets installed. And the reason it's in a separate place is because a lot of these things are actually repeatable in various different places. They're not always just used for a single component. So here is our media definition for orchestrator. Here is how the downloader knows how to go and get it. So what URL to go and download that from and how to treat it once it's been downloaded. And then these are the different items that can be installed from within this. So when I'm installing my orchestrator management server, I have a validation section. This is how we determine whether or not it's already installed, and after we install it, whether or not it was successfully installed. And then a set of parameters for a command line. What you see in here is a lot of these parameters have variables in them. So all the information that's either defaulted from workflow or comes from the variable XML file that you define is substituted when this command line is created by the installer so it knows how to go and install it. There's also condition sections in here. So this particular part of the command line is where orchestrator is given its product key. If you haven't given me a product key, I can't give orchestrator a product key and it will fail if that parameter is blank. So the condition says I'm not going to supply that parameter to that command line unless I've been given it. So there's lots of conditions that will make the command line be dynamic based on whatever you've specified to deploy. Full reference for all unattended silent installs for everything involved in System Center in the workflow XML. Then we have some other sections in here that are interesting. There's the component section. These are the default variables for installing orchestrator. The only one that you saw in the variable file that needs to be replaced is the service account. But if you also wanted to specify a different web service port, a different installation directory, whether or not remoting against the orchestrator is enabled, you can change these variables. You don't change them in the workflow file. You copy the variable to the section or the variable entry to the variable file and change it in there. And then it gets really interesting in integrations, and I'm not going to go too far in this, but this is how we determine whether or not post-setup integration is needed. So this is the app controller to virtual machine manager integration. So here, what I'm basically saying is if these two roles exist in my deployment, so if I have an app controller server and I have a virtual machine manager management server, I'm automatically going to do the app controller to virtual machine manager integration, and this is whatever role, whichever server has that role on it is the server that's going to run that integration. That is then just defined as a role. Right? These can also be two-step integrations. So for example, Operations Manager and VMM. First you have to install some management packs in Operations Manager, and then you've got to go back to VMM and tell VMM, that's the Operations Manager server I want you to integrate with. So because of the ability to sequence things with dependencies, we can do that too. So here you can see the integration that happens on the Operations Manager server first. So if I've got an OM management server and a VMM management server, I'm going to run this integration on the Ops Manager server, and then same requirements, if I have those two servers, I'm going to run this integration on the VMM server. So it manages all that sequencing and integration. You don't have to know about post-setup integration anymore. The workflow file is versioned separately to PDT itself. So if we want to release some new capability here and it doesn't involve changing the core engine, the installer script, we'll just release a new version of the workflow file, and you can just plug that into your existing scripts and it will continue to work. Validation. Since we first released this in February, there have been 2 updates. The main thing that we put in the updates was additional validation. Right? Validation is pre-installation validation that we check to see that what you're trying to do should work. Can't absolutely guarantee it, but we check everything to see whether or not it should work. 2.2, the version that was released in February, had absolutely no validation in it whatsoever. It was basically the tool that my team and various others at Microsoft have been using for a while, and we didn't feel like we needed validation. But it became very obvious very quickly that use of this generally requires that we check that what you're trying to do makes sense. So there's 3 phases to validation. The first one is local. So all local validation does is check the variable XML file to make sure you aren't trying to do something that we know won't work. So if I'm trying to install an orchestrator management server, but I haven't specified an orchestrator database server, we know that won't work. If I'm trying to install 2 orchestrator management servers, we know that won't work. If I've tried to combine a operations manager management server with a service manager management server on the same system, we know that won't work. So it just checks everything about the variable file to make sure that your input is correct. That's why I say don't be too concerned about editing XML. If you do something wrong, we're going to block you. Then we check AD. So for all of the service accounts, passwords, and security principles, in other words, groups that you've specified in the variable XML file, we check that they're correct. The service account exists, the password's correct, and that security principle exists. The reason I call these security principles instead of groups is it can be a user if you want it to be, but most people actually use groups for these. This is things like the service manager administrators group that you have to specify during installation. And then we remotely check the target systems that you're installing against. We make sure that they actually exist, so you didn't get the name wrong. You have administrator access to them. If you're installing a cluster role, that the cluster already exists and all the systems that you're specifying for that cluster role are in the same cluster. WinRM's enabled, the task scheduler is enabled. Credentials policy is an interesting one, and this is a good example of how we modify this thing over time. So initially we were just checking task scheduler, but I had one piece of feedback from somebody that tried this. It was actually an internal Microsoft employee that said it didn't work. It created this task, but then the task never ran. And we spent some time trying to figure out why on earth the task didn't run. And it turned out that there's actually a policy, a Windows policy, that prevents Task Scheduler from storing user accounts and passwords. And so now we check to see whether that policy is enabled or not. So that shouldn't ever happen to anyone again. Whether or not the operating system version is compatible for the role being installed. If you have file access to it, because we've got to copy the files to that system to be installed. If there's appropriate certificates installed, this only applies to Service Provider Foundation. And if the minimum memory for the setup of the role being installed is on that system. And again, this only applies to Virtual Machine Manager. Okay. You can choose to skip one or all of these, right? So if you think we're wrong about how we're validating things, tell it to skip validation, and it will try and do what you told it to do. If it works, you might have done something that we didn't think was a good idea, but chances are if you skip validation, it's probably not going to work. So let's take a look at what validation looks like. And to do that, I'm actually going to do something wrong. So actually, while we're here, let's take a look at where we are in some of these installs. So this was my first one that I was running. Green things, green is good, of course. Green things are finished. Something that's listed in white is still running. Anything that's yellow is waiting on a dependency on some other system, right? So here, my VMM management server is waiting for the operations management server to finish its part of the integration before it can do its own part of the integration. So you get a fairly easy visual on the status of things. Second deployment, this is the HA1. The SQL cluster's finished. The VMM cluster is still installing, and everything else is waiting to complete the rest of its integration. So I was going to look at validation. So here's a variable XML file, and this is actually the same as that first deployment. This is deploy everything, but not HA. Let's make it do something bad. So for example, here's my operations management server here. Operations manager server, where is it? Up. There you go. So OM1 is my ops manager server. If I were to try and tell service manager to install on that same system, we know that's not going to work, right? So if I save that, let's a couple of lines down so you can see this. Installer, I'm going to say validate only, because those systems don't actually exist because my VM creator is still going on in the background. And in this case, actually I don't need to tell it to skip any validation, I'll just tell it to do validate only. First couple of things it's checking, fine. When it gets to checking combinations, it says that's a bad idea. Don't combine those things, that won't work. So let's put that back. Let's go and get something else wrong. Let's remove the orchestrator database server. Okay, so now I'm trying to install a management server, but not a database server. It'll tell me that I'm trying to install something that has a dependency that I'm not installing. Right? So it's trying to prevent you from doing something that you shouldn't do. Let's put that one back in. Let's go and make a password wrong for a service account. So let's take my orchestrator server and get the password wrong. Right. In this case, I'm going to skip the local installation because the local validation, because this is AD validation. So I also have this skip validation. I'm going to tell it to skip local validation. Hopefully my VPN isn't dying on me right now. There it is. So it skips all the local stuff. It goes straight to AD validation. It says this is an invalid service account. And so everything that we know, almost everything that we know that you could potentially get wrong, we attempt to validate. There are some things that we still don't validate, and I'll talk a little bit more about those in a moment here. Integration, this strange thing called post-setup integration. I asked how many there are. These are the ones that PDT actually does for you, right? It is not all of them. There are a couple that aren't automatable easily, But PDT does all of the automatable post-setup component integration. So if I'm installing an app controller on VMM, app controller's more or less useless unless you tell it about the VMM server that it's the portal for. So it will do that for you. All of the Service Manager CMDB setup, all the connectors in Service Manager that it uses to create its CMDB, PDT creates all of those for you. Apart from the Active Directory one. Active Directory isn't part of System Center, and so it doesn't do that one for you. The DPM Central Console integration with Ops Manager is another one. Everything that we know about that can be automated is done by PDT. There is one very notable missing integration here, and that is, ironically, Orchestrator integration packs. Orchestrator has no supported automation interface for registering and deploying an integration pack or creating a connection for that integration pack. I say supported because there are actually some blog posts out there that tell you how to do it with PowerShell, but it uses a completely unsupported interface, and so I really didn't want to put that in here. The other one that we don't do is actually the second part of the VMM to Ops Manager integration. So VMM Ops Manager, you tell VMM about the Ops Manager server, and then sometime later you come back and tell it about the analysis services on the Ops Manager server. That one, sometime later, basically requires that the Ops Manager reporting system has completed all of its cooking that it does after it's installed, and so we can't really determine when that is, and so I actually don't do that piece of integration. Admin groups. This is one of my favorite things that I added just recently. Every component of System Center uses a slightly different way of defining what the default admin group for that role is. Right, so Service Manager requires you to specify an admin group during installation. None of the others do. Orchestrator optionally allows you to specify one, but doesn't require it. Ops Manager, Virtual Machine Manager, App Controller all take the members of the local administrators group and add those to the administrators group for that component. Service Provider Foundation and DPM both just use local admins. And then my favorite one of all, Configuration Manager. Only the account installing the Configuration Manager site server is added to the administrator group, right? So if you do that and you use an installation account to do it, then you go and try and run the console somewhere else, you have no access. You got to go back and add that. So PDT optionally allows you to specify admin groups as part of that variable file. It requires you to do it for Service Manager because Service Manager installation requires it. Configuration Manager is slightly strange in that you have to install the Config Manager console to be able to do this, because Config Manager PowerShell is part of the console installation, not the site server installation. But it allows you to specify the admin group, which means that even though I'm using an installer service account to do all the installation, and I'm not necessarily guaranteeing what the local administrator group membership is of any server that I'm installing against, I can specify which groups should have access, so by the time my console's installed, I should just run it and I have access. One better than that though, it also configures the console to connect to the right server. Because we're doing a complete distributed deployment, I'm installing my Operations Manager management server and my Operations Manager console on potentially two different systems. Well, I know which it should connect to, so I automatically configure the console to connect to the right thing. So you don't have to go as a second step and go and add it. This is really here just for reference. So these are the groups, the variables that you put in the variable file to specify the group. They are optional. You don't have to include them with the exception of Service Manager. Then we have advanced configuration. Right? There's a lot more that this thing can do than just the relatively simple installations we've talked about right now. I showed you the components variable section in the workflow file. Any one of those can be copied to variable so you can change its setting. So if you don't want to use a default web port, if you don't want to use a default installation path, any one of those settings can be added to the variable file. If you choose to, you can use an existing SQL installation. So we find that about half of our customers, the System Center guys install their own SQL, and half of them, there's some corporate DBA group that installs SQL and you're not allowed to touch it. You just use their SQL, right? So if there's an existing SQL farm that you want to use, you can say this is on the database role, this is an existing SQL server and it will just use it. However, there is no validation for that scenario. If the SQL server doesn't exist, if you don't have the appropriate rights to it, it will fail gracefully, but it will fail. There is no validation. I really stress this one, getting SQL right. A default installation of SQL uses the system drive and puts all of its log files, database files, tempdb files on the system drive. That is the worst possible SQL installation for System Center. Right? You really want to think about planning for database performance, and so we allow you to take all the variables that specify where SQL, which drives SQL uses for each one of those items and customize it in the variable file. Even on virtual machines. So yeah. Okay, I understand the question now. So the question was, on virtual machines where all my VHDs are actually on the same storage subsystem, does it matter? I believe it does. The reason I believe it matters is because you're probably going to run into a problem unless that's an amazing storage subsystem, and so you're going to want to optimize that, and if you've started out with them on different VHDs, it's much easier to move that VHD to the right set of spindles so you get the right performance. Yes, absolutely it matters on virtual machines. Good question. We can install SQL clusters, and I'll show you the reference for how to do that. There's a blog post that details how to install SQL clusters. We can install VMM clusters. In both of these cases, the cluster has to exist before the installation will work. Right? We don't create the cluster. The main reason we don't create the cluster is because cluster storage is a massive variable, and we can't predict what that's going to be. And so you create the cluster, you define your cluster storage, and then we'll install the cluster role on top of that cluster. And then we also have scale-out roles that we can install. So a scale-out role is something like an operations manager management server. You need one, you can have more, that's a scale-out role. App controller, you can have multiple app controls in a load balance cluster. Right? We can install multiple ones. There are 3 different ways that scale-out roles get installed, and PDT understands them all. The first way is I install my first one, and then I can install additional ones. Right? Operations manager management servers is a good example of this. The first management server you install defines the database. Subsequent management servers use that existing database. So you have to install the first one first, and then you can install all the others at the same time. Some scale-out roles, you can just install them all at the same time. Right? So orchestrator runbook servers are an example of this. However, we treat them like the first one because the first one is considered the primary runbook server in orchestrator, and so we want to be able to specify which one of those it is. And then there's one particular case for sequential installation, and that's actually DPM. If I'm installing multiple DPM servers and having them use the same SQL server for their databases, which was added in 2012, I think, they have to be installed sequentially. The reason is DPM actually restarts the SQL instance during installation, so if I'm doing it concurrently, everything but one will fail. The one that restarts the instance will work and all the others will fail. So they have to be installed sequentially. So here's the reference for, and these really are in here for reference. I don't want to spend a long time on explaining these. The reference for getting SQL right, these are the variables that define where the database files, log files, tempdb files go. SQL clusters, there's 2 different ways you define that depending on what the storage is. If it's SMB storage, you specify UNC paths. If it's SAM-based storage, you specify cluster disks and drive letters. So here, installing a cluster, you'll see I'm saying on my database role, this is a SQL cluster, and here's my information about that cluster. I have to specify service accounts because SQL clusters require service accounts. And then here's my UNC paths for the file locations. IP information for the cluster that I'm creating, and then these are the nodes that I'm going to include in that cluster. Right, so I'm installing a 3-node cluster. Similarly, SAN storage, I'm using drive letters instead of UNC paths, but I also have to specify what the cluster disks are, and these have to match. We don't validate these. You just got to get this information right in the variable file. VMM clusters, instead of installing a virtual machine manager management server, I'm installing an active management server and a passive management server, but I also define the cluster name for the VMM server role and the container within AD that it uses for distributed key management. Again, we don't assume we have any access to AD, so you have to have that created before we start. And scale-out roles are just a case of understanding what the role name is, and all the role names are referenced in workflow XML, and then adding as many of those as you want. So I can do full high availability scale-out deployments of System Center using this. So yes, it can be used to do production installs. The question comes up fairly often, is this supported? We're not doing anything in an unsupported way. So everything that gets installed is installed using a supported mechanism. The only thing that is TechNet community supported is the script itself. But if you have something that's installed using an unattended installation and there's some issues with that, the unattended install is a completely supported mechanism, and product support services will support that installation. They don't actually support the PDT scripts, but they do support the installation. There is lots of troubleshooting that you can do. We log everything. So there's the installer login itself, and that is to the typical app data local location. There's a log file there for everything that installer's doing, as well as an individual one per target server. This will go through and tell you everything it's doing. So I'm checking to see whether I need a specific component installed. Then I'm installing it. Then I'm checking to see whether it's installed correctly. This does include the command lines. So every command line that PDT issues, whether it's installing a server role-in feature, a prerequisite, SQL, or a role, the full command line is listed in the installer logs. We do strip out the passwords, blank them out, but other than that, the full command line is there in that installer log. We then also collect all of the component setup logs. So PDT is just telling you the command it's running, and I can log that locally on the system running the installer, but that installation itself has its own logs. So if some part of that installation fails, I may need those logs to be able to determine why it failed. We collect those back to the installer system, so you have a central repository of all the logs for the setup. Part of the reason we need to do that is because of the way Task Scheduler works, those logs may no longer exist on the target server after something's failed. Some of them go to that temp/1, 2, etc. folder that disappears after the user that belongs to logs out. So when the task finishes, the logs that are in there disappear. And so the only way to determine why something may have failed is to copy them. So we do actually copy them. You can restart any deployment. So if something in a deployment fails and you end up with one red failure line or a couple of red failure lines on the progress screen, you can start it over. A lot of failures are timeouts. Some failures are timeouts, especially if you're doing all of this on a single Hyper-V server that doesn't have a particularly good storage subsystem. Things can time out. Very often, if you just run that installation again, it will actually work and complete the second time. It doesn't attempt to redo anything it's already done because it checks to see whether it needs to do it. Because it's already done it, it doesn't, so it just skips straight to the things that need to be done. Do be careful, though, of reboots. I can also add to my variable file, so I'm deploying additional roles in the restart of the installation, by the way. So if I've installed Orchestrator and Operations Manager, then I want to add VMM. Or if something's failed and a week later I want to go back and restart this. If any one of those machines has been put in a reboot pending state in that interval, it will get rebooted. So if it's in production, that's not a good thing to happen. So just be careful of doing this. Usually if you need to restart, you can correct whatever condition happened and restart straight away, and everything will be fine. Just a quick note on eval versus licensed. If you install everything in evaluation mode, you can change them all to license mode. Every component has the ability now to be switched from evaluation mode to licensed. Two things to note on there. The DPM media that's downloaded by downloader is eval media, so you can't use that and install it initially in license mode. You can switch it to license mode after the fact, but the installation has to be eval mode. So if you give it a product key, it will fail. If you want to initially install licensed DPM, just replace that with your volume license media and it'll work. The other thing to note is Service Manager can be upgraded from eval to licensed, but the way to do that is through a utility that's only available from support services. That's not included as part of the product, but it can now be done. So let's go back to our demo and see where we are. So here's our first one. It completed in 55 minutes. Not bad. You'll also note that on the taskbar, wait, not done yet. On the taskbar, it's automatically added all the icons for the console. The reason it did that here is the system I'm running the installer from happens to be the system that I'm installing the consoles on. So it's just, for convenience, put all those down there for you. It has also configured them to connect to the right server. So instead of running the orchestrator runbook designer, it's saying, okay, that failed, and then what do you want to connect to? Because it knows OR1 was the orchestrator server, it automatically connects you to that. Let's go to VMM. Same thing with VMM, well, with all of them. They'll all automatically connect to the right place. But I want to start a couple of these and show you some of the integration that it did. So the question was, can I install the console components without installing anything else? Yes, with the exception of the configuration manager console. All right, so if I just want to specify my consoles in variable XML and have them all installed on a system, you can do them all apart from configuration manager, because part of the silent install for the config manager console is the config manager server it needs to install to, and the only way we know that is if we've actually installed it in the first place. So here's Service Manager. Notice all of the connectors for the CMDB are already in place. All of the connectors are configured. The data warehouse is also registered, but it's still going to take it about 8 hours or so to actually cook all the reporting stuff, but it's all already there. VMM, my integration with Operations Manager is already there. So I've already configured the OM connection. I haven't configured the analysis service connection for the reason I mentioned earlier. And then I'm an old configuration manager guy from years and years ago, SMS 1.2 in 1996. My favorite. Configuration manager actually allows me to run the console. So as part of that installation, I have automatically added the admin group to administrative users. So not only is the account that did the installation an admin, but my config manager admins can actually get there. Now you can applaud. Second one, just to wrap this up with 2 minutes left, the HA deployment finished in 54 minutes. Right? This is a 3-node SQL cluster. All the storage and everything already existed, but it's a 3-node SQL cluster, a active passive VMM cluster, and multiple instances of both app controller and service provider foundation. And again, all of the consoles are automatically configured. In this case, this is a clustered VMM instance. So rather than connecting to the cluster node, it connects to the cluster resource group name. And the very last thing on here, app controller, which of course doesn't have a console, but it does require you have Silverlight installed. But we know that, so we've installed Silverlight for you so that if you're in a disconnected environment, it doesn't try to go out to the internet to get it. And if I log on here as me, you'll see that the connection from app controller to VMM already exists. That is the PowerShell Deployment Toolkit. So back to our questions. How many products are there in System Center? There really is only one now. How long does it take to install? 1 hour. In all honesty, if you're doing a full HA scale out, you've probably got a 6-node cluster with multiple instances on it. It's going to take about 2.5 to 3 hours to do that, but a lot of deployments can be as little as an hour. How many screens does it take? 1. You just edit the variable XML. That's all you need to do, right? How many post-setup integration tasks are there? Doesn't matter. It just does them. Who's afraid of XML? Okay. I welcome somebody to write a UI for this. And in fact, I've talked to a couple of people this week who are considering doing that. This is a utility. It's effectively sample code that we released for SP1 because there was no other simplified, unified deployment mechanism for it. It's very unlikely that anybody on my team will write a UI, but you're certainly welcome to do so if you want. Couple things here. This is released on the TechNet Gallery. It's available publicly to anybody that wants to use it. We got some shortened links on that. It's documented through my team's Building Clouds blog. There's a deployment track on that blog that will that documents how to use this thing, and most of what I've just been through is documented on that blog. And then if an hour is too long, there's a 2.5-minute video on YouTube that does it at 10,000% speed, so you can see the whole thing go through. It does not replace the existing deployment technologies in System Center. What we're attempting to solve is the chicken and egg problem. I need VMM to deploy and service services, but I can't deploy VMM as a service, so I need something else to do it. I want to use Configuration Manager for software distribution, but I still got to get Configuration Manager there in the first place. So thank you for your time. I'm 2 minutes over. I will be around here to answer questions, and don't forget I have not enough value $5 Starbucks cards if you're following us on Twitter. Thank you.